Good day. Today I will introduce you to another Excel spreadsheet program called RCC 41. It's a spreadsheet program designed by the Reinforced Concrete Council for the design of reinforced concrete continuous beams. Anywhere you see blue write-up or blue cells, that is where you can edit data. On the main tab, it has where you are going to input your parameters such as names, material parameters, the sizes of the beams and columns. In the spans area, that's where the reinforcements are designed. Then in the notes section, we find the version of the software. It's a public release version, and we can see the date it was released. In the first part, we have write-up where you can write your name, the name of your company, and so on and so forth. And then under materials, we can change some parameters like the strength of concrete, the strength of the steel, and so on. And then on the span section, we can easily see that the program can design up to 6 spans. So we have the length, the height, the BWHF, the type of design, and of course the BF. These are parameters for beam design. On the support section, it's the columns, the column above and below the beams, and so on and so forth. And we can see that we can enter up to 7 supports. And under the loading section, we can also see that it can accommodate both a uniform distributed load and a point load. This is a structural plan, and we can see the columns here and the lines, the thick lines are the beams, and these square box are the columns. And we can see the slab panels. The slab panels are the kind of empty spaces between the beams, and then we can see the symbol which tells us that the slab is a one-way slab. Now we are going to be designing the beams on grid 3. Now the size of the beams are a depth of 550 mm and of course a breadth of 300 mm. The thickness of the slab is 150. Now the distance, the length of each beam is 8.5 meters. A little consideration will show that if you are going to design these beams on grid line 3 as a continuous beam, it should be considered as a T-beam. Meanwhile, the loading have been previously calculated, and so we have a distributed load going to the beam from the slab as 22 kilonewton per meter for dead load and 15 kilonewton per meter for live loads. So now going back to the program, now FCU is the strength of our concrete, so we can make it 30. FYL, we can make it 450, and we can leave this FYV as 250. Let's change all the cover to 25. Okay. Now we have 3 spans. So this is 1 span, 2 span, and 3 span, but they're all of the same sizes. So the length of each span is 8.5. So we're going to input 8.5, that's 8.5, and 8.5, and the third span, that is 8.5. The height of the beam, as we have seen before, is 550. So we are going to input 550, 550, and 550. So the BW is the same as the width of the beam, which is 300. So we're going to input 300, 300, 300, and 300. Now the HF is equal to the thickness of the slab, and which is 150 mm, 150 mm, and 150 mm. And the type, so in this case we want to design as a T-beam, so we are going to change the R here to a capital T. Now look at BF. There's a way to calculate BF, but the program actually calculates BF for you. So we can take the values of the BF that is shown in the program itself, or we can calculate it based on the code. Now we can leave the supports. We are not really designing the columns, but they are going to play some role, but not so critical in this situation. We just want to design the beams, but of course if you know the size of the columns, you can enter them, because they do affect the design in one way or the other and make design more accurate. In the loading section, I said earlier, we have picked a loading, a dead loading, which has been calculated from the slab as 22 kilonewtons per meter. So let's include that 22. We're going to change the imposed loading is 15. So you're going to do it for span 2 and span 3. The same, 22, 15, and the span 3. We'll click on the UDL and 22 and 15. After we have inputted all the parameters and we have cross-checked them that they are correct, and we are not really seeing any error or complaints for the program, we cannot go into spans. There, in the spans, that's where we see our design for the beam, the steel design for the beam, and we'll study them all carefully. For instance, in span 1 at the center, it recommends a 3y16. Towards the right of the beam, it recommends a 2y32. Of course, this may not be intelligently chosen. We can actually change it. You can see it designs all the steel, even including the top steel. You will see that there are some errors. There's some errors. These errors are related to the bar spacing requirements, and they are not critical for this design, but you can try to see how you can eliminate them, maybe by increasing the size of the beam, or by reducing the diameter of the reinforcement steel provided by the software. So this is how you can use RCC 41 to design reinforced concrete beams. I hope you enjoyed this video. Please click the subscribe button and support my channel. Thanks for watching. Bye for now.